You have learned in school b squared minus 4ac is less than 0. There's no real roots. We know that for any equation of this form, the solution is x equals to minus b plus minus square roots b squared minus 4ac over 2a. So take for example, if we have 2x squared plus 4x minus 2 equals to 0, then we know the solution to this is x equals to minus 4 plus minus square root b squared minus 4ac over 2a. But suppose this value you see in this case is a positive number because 4 to 8, 8 to 16, then minus is a plus. So 16 plus 16 is 32. So we have this minus 4 plus minus square roots 32 over 4. Then because the b squared minus 4ac is actually the thing over here. This is b squared minus 4ac. So if b squared minus 4ac in this case would be greater than 0. It's a positive number. So when you square root it, it will give you a real number. When you square root a negative number, like negative 2, something called root 2i, which we learned in junior college, this is a complex number. This is an imaginary number. This is not real. And that's the reason why they say if this is a negative number, there's no real roots, even though it's an imaginary root. But we leave it to junior college. Now we just need to know that there's no real roots for when we have. Therefore, right, b squared is when it is less than 0, then we say that there's no real roots. But for this particular example, because the b squared is greater than 0, we will have 2 real roots. Why do we have 2 real roots? Means there are 2 real number roots that are distinct. Why distinct? Because one of them will be minus 4 plus root 32 over 4, whereas the other number will be minus 4 minus root 32 over 4. So these are 2 real number roots and they are distinct. That's why we say that there are 2 real distinct roots. What if we have x minus x2x plus 1 when it's equals to 0? So let's check the discriminant of this. The solution of this equation will be x equals to minus b square root b squared minus 4ac over the 2a. This one, in this case, we see that this will become 4 and then minus 4. So the minus 4ac for this particular case is equals to 0. And when this is equals to 0, plus minus 0 gives you the same root. We see that this is 2. 2 divided by 2 is 1. This part gives 0. Square root of 0 is still 0. Hence, we see that there's only one root, or sometimes we say that it is 2 equal real roots. Why do we say that it's 2 equal real roots? Because actually this can be factorized, and then it can be factorized into x minus 1 squared. Because x minus 1 squared, when we expand, will be x squared minus 2x plus 1. So this is x minus 1 squared equals to 0. In other words, the two solutions are the 2 real roots. They are equal, x equals to 1, or from here, x equals to 1. So these 2 real roots, are actually equal in value. So actually, it's really just one solution. So that explains why b squared minus 4ac, when it is greater than 0, we have 2 real roots. And when b squared minus 4ac is equals to 0, we have 2 real roots also. But this one is 2 real and equal roots, because the 2 real roots are equal in value. Whereas this one, we say that it is 2 real and distinct roots, or 2 distinct real roots. That's the reason behind the discriminant. Okay, so sometimes we get slightly more complicated questions, like when we say y equals to 2x, and then we have another equation y equals to x squared minus 3. Then we use discriminant to judge whether these two curves intersect with each other. So graphically, x squared minus 3 is this. This is minus 3. And then we have a y equals to 2x. Graphically, we will know that there are actually 2 solutions. But how do we know that? So let's say if we have y equals to, if we simultaneous these 2 equations, then it will become x squared minus 3 equals to 2x. And then when we move it to this side, x squared, then we minus 2x. Then checking the b, this is b, then this is the a, and then this is the c. checking the b square minus 4ac, which is equals to minus 2 square minus 4 times of 1 times minus 3. This is 12 plus 4, which is 16, which is greater than 0. Since it's greater than 0, there's two distinct real roots, which agree with what we have here, that there's two intersection between the two graphs of y equals to x squared minus 3 and y equals to 2x. Because the number of solutions of the intersection, right, these two equation will, when you simultaneous equation, will become just this one equation, the equation 3. The equation 1 and 2, when you simultaneous equation them, then you will just get the equation 3. And the number of solutions to this is the number of solutions to the intersection of these two. That's why we can use discriminant here to find the discriminant of this to determine how many solutions there are to these equations, and hence the number of solutions we have to this equation would be the number of intersection between these two graphs or these two equations here. Okay, have question, feel free to reach out to me, so we can have a online 30 minutes free lesson trial.